Alright, here are solutions to perfect problem 6 for Math 65. Okay, so what we do here is recognize, recognize difference of squares. So the idea with difference of squares is that anytime you have a squared minus b squared, you can rewrite that as a minus b times a plus b. So this is the general formula. And a and b can be any numbers or letters in this case. So what I was hoping you'd see is that x to the 8th is something squared. It's actually x to the 4th squared, right? X to the 4th times x to the 4th is x to the 8th. So what I have here, this x to the 8th minus 65, 61, is really just x to the 4th squared minus, see, 65, 61 I gave you was 81 squared. So if you recognize, really this is just a difference of squares. It just looks a little bit different. So the a in this case is x to the 4th, and the b is 81. So I can write this as x to the 4th minus 81 times x to the 4th plus 81. But it turns out you're not done here. You're done with this guy, x to the 4th plus 81. There's nothing you can do. But as I mentioned up here, you want to look for difference of squares repeatedly. This x to the 4th minus 81 is, again, a difference of squares. So what we can do is say, oh, x to the 4th minus 81, that's really just x squared minus 9 times x squared plus 9. So what I did there is I left this x to the 4th plus 81 alone. That just went straight down here. But instead of x to the 4th minus 81, I said x to the 4th is x squared squared, and 81 is 9 squared. So this is a difference of squares. It's x squared minus 9 times x squared plus 9. And now what I have is this one and this one. There's nothing further I can do. But here I have one more difference of squared. X squared's difference of squares. X squared minus 9 is x minus 3 times x plus 3. And then I still have this x squared plus 9. And then finally over here, x to the 4th plus 81. And so this polynomial I had up here, x to the 8th minus 6,651, factors down to this form right here. And all four of these are prime. There's nowhere further you can go with this. So therefore, that's the end of this perfect problem.